So basically, these are the topics that we will be covering in today's session. So that is OSI model, TCP IP model. Then sorry, this or I think I didn't edit this. Sorry. So these are so just ignore this slide. But we will be seeing what is client server model firstly. Okay. So we need to understand the client server model in order to understand some basic concepts in application security. That's why I'm going through this slide, like a software design pattern dividing application into two parts. So basically, an application will have two parts. That is the client, another is server. Okay, client means runs on the user's device. So whatever, let's take an example of Facebook and anything. So which runs on the user device, right? It handles the user interface. So whatever the user interface which we like open, so that is nothing but our client, right? So we will be getting login page, we will be going through our account. Okay, we will be posting some pictures like that. So those are all comes under the client. So it what is manages the application look, feel, and user interactions. So uses local resources like storage and processing power. So this is how like it was. So it uses the local storage, means the laptop storage it uses for processing power. Like let's say if your laptop has less RAM or like that, so it will be little low, so little slow you can say the application. So that entirely depends on your laptop. So that is client. Okay. Then server side. Server side means the process client requests and response via an API. So basically, whatever you get, you will be sending that to this server, right? That is known as the request. Okay. Whatever you will be getting from the server, right? That is known as the response. Okay. So may include a database for storing persistent data. So at the server side, there will be a database also to store the permanent data, to store the credentials, to store the details. So it also requires the database. So key advantage, flexibility to cross-platform user interface while ensuring consistent experiences across devices. Like cross-platform user interface means it can handle different kind of a user interface at the client. Let's say if you are using laptop, so it can show you the laptop user interface. If you are using the mobile, so it can show the mobile interface. If you are using tab, so like that. So even any application, right? So they design like that, and they also test properly. So whether it is working in mobile properly or not, whether it is working in tab or not, whether it is working in laptop or PC or not. Also, they check the user interface also. Okay, let's say in mobile, if it is showing only half of the page, so then it is not a proper application that is deployed. Or it is not deployed on properly on Android like that. So like that, they will also check the testers. So basically, I just want to tell you this: whatever the applications are there right now, so those are our client server model. So previously, there were only one uh, monolithic something it used to say, only one laptop, means the application will be on the same laptop like that, with less memory like that. It was not having much data to store on the server. That's why on the same laptop you can download and use that. But now what happened? So the data has been increased. So that's why previously means it's very long ago. So the first you can say first time how it was interaction. So that I'm saying. But now all the applications are following this client server model only. Okay, shall we move to next slide?
Yeah. Yeah.
Then let us see what is IP address. So IP address is basically a kind of a logical, it's also known as the logical address. So it is basically an unique identifier for devices on the internet. Okay, let's say you have your mobile, you have your laptop, you have like I have my laptop, I have my mobile. So every device has their own IP address. So it will be different from other. So basically this is the unique identifier. So let's say how uh, let's say your home is there. For this there will be some kind of a house number or like that, right? A unique identifier. Similarly, like IP address is also same for the laptop or devices, mobiles, like that. Which whatever it there in the internet, so it will be there like that. It will be have a different IP address. So use it to send and retrieve data between the devices. Yeah, this is the exact like usage of the uh, IP address. So why I am covering these all is actually I will be only going through the like OSI model today. But before that, understanding that concept, right, OSI model, so we need to understand some basic terminologies. So that's why I'm going through all this. Then it sends and receives data between the devices. Which devices means, let's say, if you are in an office, not office, let's say if you want to send data from, so I want to send you some hi or like that message in WhatsApp or like that. So it will be identified through the IP address to you. It will reach to you through IP address. Okay, or else not this message or like that sender or receiver. Just take the client and server model. Okay, so assume this is my client. So here I am opening my YouTube page. Means I am opening my YouTube means like the YouTube application. So once I open the YouTube application, so there will be request going to the server. Okay, so this request will have to have a destination, right? Which server that you need to go. So that is nothing but YouTube server, right? So this entire communication will be going in internet. Okay, internet it will be going through, right? So that's why it need to have some destination. So where that server request need to go, where that client request need to go. So that's why there will be a unique identifier. So that is IP address. So IP address will be unique identifier to find this its server for the client. So entire how the from the internet the communication goes, that we will be seeing in detail. It while explaining OSI model, I will then indicates the origin and destination of data. Okay. I've said right, like which origin means from which client it is getting, from which server it is going, to which server it is going, like that. IP address are assigned by the INA. So this is the Internet Assigned Numbers Authority, which assigns the IP address to the systems. Yeah, it gives some IP address. Let's say I'm like I want to put an office. Okay, so I want like 50 systems. I have 50 systems. So with that systems, I require IP addresses. So that IP addresses will be assigned by this team, and it should be private or public. So there will be different types of IP address, like private IP, public IP, like that. So that so private IP means it can be only accessed in a room, you can say. Okay, So it is just it will not available to the internet. So other than what we can say, let's say if you are in the office, right? So your system, your colleague system, so everyone will having separate IP address. So that IP address will be private IP because you are in separate environment. You can say you are not connected to any kind of internet. So you will be connected to VPN. So when you connect to VPN, right? So there you will be assigned to a private IP. So you will be giving a private IP. So like that. Then versions of the IP address. So there will be two versions, IPv4, IPv6. So 32-bit. So this is how it looks like. This is we are using right now. So this supports 4 billion addresses, 32-bit IP address, whereas 128-bit supports trillion IP addresses. So it can generate trillion IP addresses. So this is how it looks like. Then comes the types of IP addresses. So static IP, so which can be permanent. Example servers. Okay, let's say YouTube server, Google server, Facebook server. All that IP addresses will be permanent IP address, which will given to them. Okay, that cannot be changed. So then dynamic, temporary home networks. So if you are home networks or office networks, so we will be having some temporary IP address. So that will not be like permanent IP address. That can be changed. Okay. The public IP addresses like enables internet connectivity, use VPNs for proxies for privacy. So this is public. Sometimes we can use here public and private will be there too actually. So this private will be some set of IPs that will given to person let's say a group or like that. So they can use privately without connecting to the internet. So if they want to send any data using the LAN like that, so at that time they can use these IP addresses. Also, if you want to hide your IP, so you can connect to this private IPs. Okay, so this is the basic intro about IP addresses. Then coming to the MAC address. So MAC address is basically it is also a unique identifier, but for each network interface controller, network interface card, you can say actually, network interface card or controller. So present in your system. Let's say your Bluetooth. You will be having Bluetooth. You will be having LAN port. You will be having Wi-Fi port. For each port, you will have different MAC address for your laptop. Okay, that is media access control address. So used in Ethernet, Wi-Fi, Bluetooth, etc. Format. So this is how it looks like. Hexadecimal digits. Then first three groups manufacturer ID. This three will be manufacturer ID. Then device specific ID. Next will be device specific ID identifiers. How do MAC address work? Operate at the layer 2 data link layer of the OSI model. Facilitated communication between devices on the same network. Just remember this same network for MAC address. Act like a house address, guiding data to its destination. So actually, it's you can say only like for one apartment there will be having different numbers like that. So different house will have different number like in a big apartment. So like that it will be considered like MAC address. Like you will be having different ports. You will have the Bluetooth ports. You will be having Wi-Fi port. So for that listening for any port, you require different network interface card. Okay, your laptop will have multiple interfaces card. Okay, so that for each interface you will have different MAC address. So burned into the NIC by manufacturer keypads. like essential for device identification within the local networks. Uh, Local networks. So just remember that actually. So just a minute, I will show you how does it looks like. So if you want to check IP config all, so just type like that IP config all, you will get your IP address. Oh, sorry. Okay. Yeah, here I think IP config all not required. IP config access. So here you can see this is all my details from where it is starting. Hyphen all, show all detail information. Okay.
Can get here down over there.
My IP address. Then for LAN, so there will be media access control. So these are not showing instrument IP. What was that? IP slash all. Okay. Now you can see these are different interfaces cards for not this. So this is like no, it's IPv4, but actually temporary IPv6, not this. Media state disconnected. Where is wireless? Yeah. So MAC address is also known as physical address. IP address is also known as logical address. Okay. So this is my network interface card MAC address, Ethernet adapter port. Okay. I think this is it should be, I think, for my pen tab which I've connected, maybe another physical address for wireless LAN, then wireless LAN local area connection to, this is the another one. So you can see different physical address. So we have only one IP address. So this is the IPv4 address for my system, and these are all the like physical address that is known as MAC address. You can see this is for each network interface card. So these many interfaces cards are there. Like for wireless LAN adapter, I have one interface card. This I have one interface card. Then this is another interface card. So like that, I think it's five interface cards are there for my system. So this is about MAC address. Then comes to the DNS. So DNS is nothing but a domain name system which is used to resolve the IP addresses. Okay, resolving the IP addresses in this sense. Let's say sometimes what we do, we search for Google. Means every time we search for the domain names only, right? We don't search with the IP address. Domain names. So that is nothing but www.google.com or facebook.com or youtube.com. But when that request, so when you search like this, right, what happens? There will be a request that will going from your laptop, means your client, to server, right? Where from where it is going? From your laptop to through which it is going? Through the internet, right?
Yeah.
So through the internet it will be going. So while entering into the internet, so in order to have some destination path or like that, so it requires the IP address. Okay, it requires IP address for identifier. Where which server is that? So to identify in the internet, right, we require the IP address. That's why, this system is introduced, like DNS server. So what it do, it resolves the IP address. Means if you enter this www.google.com, right, it will search for the Google server IP address. Then again, if you enter www.youtube.com, it will search for, it will not search, actually it will resolve to its IP address, like that. So once it got the IP address, it will go to the server. Then it will be, uh, so it will go to the Google server or Facebook server or any server corresponding to the client, and it will send a response back. Also, if you enter any IP address, right, instead of google.com, if you enter IP address only, HTTPS something, you have entered 92 192 168 dot something like that. So now it will resolve the domain names as well. So it will have a table. Okay, this will store one table basically, like this domain name, this IP address. Okay, like that it will be have a kind of a table in the at the DNS server. It matches with them, like which domain name's IP address is this. So it's like a internet phone book connecting to user website, you can say. How DNS works: user types a URL into a browser. The browser sends a DNS query to the corresponding IP address. DNS servers responds with the IP address, enabling the connection. So this is how it works. So it's just a basic introduction I just want to give on this. So DNS server responds to the query. DNS record holds information. A record for IP mapping. So like that, it will hold the information, like for Google, which IP address is there, Google server. For YouTube server, which IP address is there. So it will maintain a record. So like that. Then caching temporarily stores results to speed up future queries. So let's say, like if you want to run, means if it required to run again the same query, right, it will have some cache storage. So at the time, you don't need to find any IP address or like that. So it will be having the cache, the storage, and it gives the, I think, responses from there itself. Then what are TCP and UDP protocol? So these are two main protocols. So basically, what is the protocol is, so protocol is the, like you can say, like a kind of a rule, okay, which process you need to follow, like that. Let's say transmission control protocol is there, right? So if you want to connect to from client to the server, so with a good connection, and if you want to have without any like without any kind of a data loss in between, so you need to use this protocol, transmission control protocol. Protocol is nothing but a process, you can say, in networking. So basically TCP and UDP, these are the two that will be operated at the network transport layer to send the data. So reliable and connection oriented protocol. It ensures data is delivered without any errors and in sequence. So in sequence and without any error. So this is like TCP protocol. Then let's say if you want to send any email, right? So if you want to send any email, so we require the proper connection there, because we don't want to lose any kind of a data packets in between. Okay, so whatever the data of the client and the server which will be sending, right? So those are known as data packets in networking. Those are known as data packets in networking. Okay, so web browsing for HTTP and HTTPS also, we don't want to lose any packet in between. Let's say I want to search any YouTube page, so I don't want to lose any kind of a image or like that in between in the internet. So that's why I will use the TCP protocol there. Then file transfer. Let's say if you want to transfer any file to one person to other, so there also I don't want to lose any kind of a data. That's why I will use the TCP protocol. So TCP is the connection oriented protocol and it is reliable. So it will not lose any data in between in the internet. But whereas UDP, so UDP is used for fast connectionless protocol. So no error checking, making it lightweight. So basically what is UDP used for is, let's say if you are video streaming, if you are on a video call like that. So there we don't want the connection and we don't want the reliability. So there what we require fast, right? Let's say if I open the video call and whatever I said, if it is not immediately going in the video call, so then it is of no use, right? So that's why here we use the UDP protocol, user datagram protocol. So these are used for video streaming, online gamings, DNS queries. So we use the UDP protocol. So these two are the main protocol which need to be used, okay, while connecting to internet. So it decides whether this request need to go with TCP or UDP. Like that. Reliable, slower, guarantee delivery. Okay. Unreliable, faster, no delivery guarantee is UDP. So this is all basic differences. Any doubts here? Till then,
No.
I will just connect all these points at OSI model. Then you will be able to understood easily.
Okay.
So then ports. So ports are nothing but virtual points, network connection at start and end. So this is like there will be different ports, like we have from 0 to 1023 standardized ports. Like HTTP is one of them. HTTPS 443 is one of them. So this is the port number of HTTP. For SSH we have 22 port number. For FTP, what is the port number?
23. 21.
HTTPS we have 443. So we have 443. So like that, these are some ports. Then so ports are nothing but virtual points where network connections start and end, used to differentiate between multiple services on same device. Let's say on the same device, if you want to connect to HTTP, so you will use 80 port. If you want to do HTTPS, you will use 443. Means, let's say on my laptop, if I want to connect to SSH, I want to take some terminal. Which port I will use? I will use 22. So like that. That is differentiating the usage or on multiple services on same device. So we this differentiates port numbers. Real time example: imagine a server as an apartment building and ports as a specific apartment number, not apartment number. Basically, what you can say, doors to an house. You can say. So there is one house like that. For that home, there will be having different opening points, right? Windows could be one, right? For the main door, the back door could be another. So these are different ways to enter into the system. Ports are nothing but different ways to enter into the system. Different entries, you can say, not different ways, different entries to into the system. Ports. Well-known ports are these. Register ports are these, like used by specific applications only. Then actually the ports will be from 0 to 65535. So this is the number of ports. So Dynamic and private ports are these are temporarily assigned. So SMTP is 25 port. For emailing, we use the 25 port. Then what are switches and routers? So switches operates at the data link layer of the OSI model. It connects within the same network. So this is the switch. So switch is used to connect to devices. Okay. Whereas router is used to connect to networks. Connect two networks. So if you want to connect two networks, you require the routers. So connects the devices with the same network, uses MAC address to forward data. So what we have seen in MAC addresses, you can see communication between devices on same network. Okay, just remember that. So here you can say uses MAC addresses to forward data because switches operates at the same network. Only sync the if you want to connect anything on one network, right? You use the switches like Office. For Office network, we use the switches to connect all the devices like that. Then router. So what it does is it uses to send data from one network to other network. Okay, from Office network to some other which is available in the internet. So that's why you require a router there. So it operates at the layer 3 network layer, connects different networks, uses IP address to forward data between networks. So switch uses the MAC address, router uses the IP address to find its destination where need to send the data like that. Key differences: switch works within a single network with no IP addressing. Router directs traffic between multiple networks and uses IP addressing. Okay, so we move to next slide.
Yes. Yeah.
Then comes the OSI model. So OSI model is what you can say. It's a theoretical model. Okay, it's a theoretical model. This was designed to understand the how how the internet works or how should be the internet work. Actually, this all was designed, I think, in 1960, 1960 or 61, something it was there. So at that time, they have designed this technology, the US government. So they have did this all. Like there will be from physical layer, data link layer, network layer, transport layer. So you can see physical data link, network, transport, session layer, presentation layer, application layer. This is, but it was not implemented. Okay, it was only a conceptual framework. Okay, it was not implemented on the any applications. It was only a conceptual framework, but TCP/IP model it was implemented. Okay, it is this is the one which we are following now. TCP/IP model, but this was referred from the OSI model only. Okay, this was referred from the OSI model. Like you can see, application layer, presentation layer, session layer. They have converted this to only one layer, application layer. Then transport layer is same, and network layer is called as internet layer here. Both physical layer and data link layer has combinedly said as network access layer in TCP/IP model. Okay, so why we require this is, let's say uh, there is if you want to develop any application, right? This will be the architecture for it. You can say, or this is how the network traffic and in the entire client to the server, entire the model goes, entire what you can say data transfer will be done. Okay. Firstly, like transmits between the over physical medium. So from here there will be some wires, cables. So these are all done will be at very speed. Okay. Like first application layer, end user software. So here these are the protocols that it will be using: HTTP, HTTPS, and FTP. So which protocol need to be used, that will be defined here. Okay. Let's say I want to send a file. So at the application layer, what it will do? It will set a protocol. What protocol? FTP. Then presentation layer, data translation and encryption. So here it will be using SSL. So it will encrypt the data at the presentation layer. Then session manages sessions between the systems. Like session is nothing but connecting to other server or other client or like that. If it is other receiver who want to receive, there it will be managing the session, maintains connections and is responsible for controlling ports. Also port also will be defined here, and session. Okay, which port it is? 22, 20, sorry, 21. So like that. Then transport layer transmits data using the transmission protocols, including TCP and UDP. So which protocol need to be used here, that it will be decided, like TCP or UDP. Between these two, which need to be used. So that will be decided in the transport layer. Then it will enter into the network. Okay, decides which physical path the data will be take. So here what will be there? Router will be there. So this router will decide which path it need to be choose. Then data link layer. Here there will be switches, defines the format of data on the network. So which data it is, so like that it will be defined in the network. And also here there will be switches through which it will be addressing to its entire, like let's say first it will be from another network, right? Then when it comes to the network, right, it will be using switches to find the destination, like that. Then physical transmits raw bit between over the physical medium. So when it reaches to the right, so it uses some wires or like that, like cables. Then it will go to the other persons, whoever the receiver will be there, right? Two is physical layer, two is application data link layer, two is network layer, two is session layer, two is presentation layer. Then it shows in there in is a laptop user interface. So if I'm transferring a file, then it will receive into his laptop, any folder or like. So this is how data goes in the internet. Okay, let's say I will take an example. So now what I did, I just open the YouTube. Okay, so for YouTube, uh, which protocol need to be used? Can you answer me? TCP or UDP?
TCP.
Actually, we need to use both. Okay, by means, so this is the pages, right, or this is the content, you can say, which I don't want to miss. So I don't want to drop any packet of it. And also this is the video content, right? So video content uses which protocol? UDP,
UDP.
right? So that's why here in transport layer it will define like both TCP and UDP protocol, so that need to be used. So when I have sent this, right, so I will be sending a request and I will receive a response from the server. So along with like which protocol, everything. So that will be also like defined there. So this is how a request sends. So this is all the OSI model only. So whatever we have gone through. So I have just opened the youtube.com. So it followed the OSI model structure only, or TCP IP model, because it was implemented. Means it has have entered that in the my application layer, that is my Google Chrome. I have entered youtube.com. So once I have entered it, so which protocol it need to be used for so it will what which protocol did you use it application layer? HTTPS, right? I have searched with, because it is a browsing. So browsing is with browsing is used done by using HTTPS protocol, right? Browsing is done. So with that protocol, it gets searched here. So then when it go to the presentation layer, what it will be adding its encryption to the data, whatever we are sending from the YouTube request. In the YouTube request, it will enter the, sorry, it will be encrypting the that data because it is going to internet now. So everything which goes to internet that need to be encrypted. Okay. Then manage sessions means it connects sessions with the YouTube server. It will manage the session between the YouTube server at the session layer. Then comes the which protocol. So it will set the TCP and UDP protocols need to be used for transmitting the data. Then at the network layer, it will go to the router first. So through my router or any other router, it will check where is the server of the YouTube, and it will go to that server. And in that same network, it will search with the switches. Okay. It will search with the switches and MAC address. Here router with IP address. Here switches with MAC address. Then it will find the data and it will respond again. So with the physical layer like wires or anywhere. So it will go to that, and again it comes back with the wire, and again it used to do my again it will be a reverse process now to wire through switches to network. So then it reaches to me. So this is how an internet communication works. So this is the implemented model. This is the conceptual model. So if you learn this, this is also very similar. That's not combines OSI model application layer and presentation layer and system layer here. So here, whatever, like here we set all the, like we do encryption in this application layer. We select which protocol like HTTPS or HTTP or FTP. So that will be defined here like that. In transport layer directly it will check what TCP or UDP we need to set. Then internet layer means network layer. So where it will be going through like routers. So network access layer, it will going through switches and physical layers. So like that. So responsible for the reliable transmission, UDP or TCP handles routing and addressing internet layer. Then network access layer combines the data link and physical layers. So this is all about TCP and your IP model and OSI model. That's why I have gone through some basics first. Then I have covered this OSI model. Actually, this I So again, I want to show you like for TCP, why it is connection. This might be an interview question. Just a minute, I will tell you. So do you heard about TCP handshake by any time? So three-way handshake, TCP handshake, it will be saying like there will be a handshake will be done between the client and the server. That's why TCP is a connection and a reliable model and a reliable protocol. So like that it will be there. So once it will be sending sync. So one then it will send a sync plus acknowledgement to again back to this client side. Then this will be sending to acknowledged. Like first what we do. So this is my client. Let's say YouTube client. This is my YouTube server. Okay. So what happens? I want to this YouTube client will be sending a sync message that I want to synchronize with you. Then it will synchronize plus acknowledgement, and a message will be sent to back to client from the server. Then it again send back to server like acknowledged. So this is known as three-way handshake. So that's why TCP protocol is a connection and it is reliable protocol. Okay, because it has the connection between the client and the server while sending the data. So I will show you what is sync and all. So you can see this is the TCP, right? So here it is sending sync. So these are all data packets. I think I got this from internet. So this is from Wireshark or something. So packet sniffing tool. Uh, this is sync, then sequence, like this it will be going. Then this is also another request with sync it is going. Again, it will be getting the sync plus acknowledgement for TCP. Then you acknowledge it. The client acknowledges it. So this is how sync acknowledge and acknowledge. These are the three-way handshake it does. But coming to UDP, you can see there is no sync, there is no acknowledge, there is no sync plus acknowledge. It is only sending directly data. Okay, this is the source IP. This is the destination IP. Source and destination. So from where it is coming, which client, which server it is going, or which sender, which receiver it is going. Okay. Good. Basic concepts.
Yeah.
Yes.
So basically, my aim was to explain you the OSI model and TCP, and in that only we will be having these all terminologies like switches, routers, uh, DNS, MAC address. So like that. Okay, that's it for today. So thank you.